Yes, I am. Thanks. All right, this looks like what we did yesterday, and it is because we didn't quite finish yesterday. So let's continue with that. I think we pretty much finished what we wanted. That first example. Yeah, we did the slopes, we did the three distances, but now we're going to talk about how it all goes together. So let's do that. First of all, I'm going to give you a definition. Oops, I got to change this. I'm going to give you a definition of something that we're going to do, and then I'm going to show you, I'll just follow along. Okay, so it's the definition of, here's the words, new. It's actually both words we've seen before, we just haven't seen them put together. All right, so it's mid-segment. Okay, what in the world is a mid-segment? Well, you know what a segment is, right? Starts and stops. And then what do you think of when you think of mid? In the middle, exactly. All right, so it is pretty simple. So let me grab a triangle here. Let's grab this one. What? So here's what the definition of a mid-segment is. I'll read it to you. I'm not going to write it down, but I will describe it on this picture, this triangle right here. It says a mid-segment is a segment that connects the midpoints of two of the sides of the triangles. You hear what I just said? Some of you didn't because you're still talking. I understand. Let's try this again. It says the definition of a mid-segment, it connects the midpoints of two sides of a triangle. So what are we going to have to do to both of these sides of the triangle? Find the what? Find the midpoint, that's right. So if I scooch over to about right there, that should be the midpoint of that triangle. Let's do it again. And if I scooch it over there, does that look about the middle? About right there? Oops, what did I just do? Let me, about right there. All right, so, may not be perfect, but it's close enough. So what I did is I found the midpoint. No, I don't label this, that's okay. What I did is I found the midpoint of two sides of a triangle. All right, and the mid-segment, I haven't even drawn the mid-segment yet. The mid-segment is a segment that connects the midpoints of two sides of a triangle. All right, so here's, I'll tell you what, let's do this just for fun. Where's the middle of this one? I'd say about right there. I'm just eyeballing it. That looks kind of in the middle, doesn't it, of that one? What we're going to do is we're going to connect the midpoints. So if I connect this midpoint right there, guess what I just drew? Let's put it in a different color. Let's make it light blue. Okay, see that blue one right there? So what did I just draw? I just drew a what? A mid-segment, that's right. Say this blue one right here is a mid-segment. Why is it a mid-segment? Because it connected the midpoints of two sides of a triangle. Well, how do I know it's a midpoint? Well, if I did this, if I said that this side was equal to this side, or this segment, I'm sorry, see this little bit right there, this little bit right there? If they're equal to each other, where's this point? It's in the middle, isn't it? So that's a midpoint. What if I said that this little segment and this little segment were equal to each other? All right, so this segment and this segment are the same, so where is this point? It's right in the middle, isn't it? So this is the midpoint of two sides of a triangle. I connected it, therefore I have a mid-segment. All right, so that's basically the definition of a mid-segment. Well, there's not just one mid-segment because I could connect two other midpoints, couldn't I? All right, so let's do that. Let's do that in a different color. So what if I connected from this midpoint to this midpoint? Guess what I have? I have another what? Mid-segment. So the blue one's a mid-segment and the yellow one's a mid-segment. Again, why is it a mid-segment? Because we connected the what? The dots. Not just dots. They're specific. They're specific points. They're not just any points. The midpoint, okay? You connected the midpoints. I said it like 5 times already before I asked you the question. So a midsegment connects the midpoints of two segments or two sides of a triangle. Are there any other midsegments in here? Yeah, there's one more, isn't there? So this is a midpoint and this is a midpoint. So watch this. If I connect them, that's also a midsegment. And you're like, well, big deal. Who cares? Well, I would agree with you. But there is something that's true about a midsegment. Tell you what, I'm just going to show you what's true about it. I'm going to go in a different order. Usually what I do is I do some math, and then we like discover it. We're like, oh, check this out. And then we come up with the theorem. We said, oh, if that's true, then here's the theorem. So, but I'm going to go the opposite way. I am going to tell you what the theorem says, and then we're going to draw another triangle. We're going to put some points in here. We're going to do some math, right? Do you remember that math we did yesterday? We found the slope, and we found what? The distance, okay? We're going to do that as well. So we are going to do some math with this, but I'm going to tell you right now what the midsegment, let me change this color to white. We have a theorem about the midsegment. And guess what they name this theorem? Yeah, pretty good, okay? That's close. It's triangle midsegment theorem, okay? But that's all right. It's the triangle midsegment theorem. Now, if it's a theorem, what do we say about a theorem? It can be what? Proven. That's right. We can prove a theorem. Now, I actually have it in my notes to do the proof. I don't think you guys are ready for the proof, so I'm not going to do that, okay? But we will do an example that kind of shows you. It's in the book if you want to look. If you're really concerned about it, it's in the book, and you can look at the proof. But what was I about to say? I was about to say something, I forget. Anyway, there's the name of the triangle midsegment theorem. Now, what does the theorem say? Now, let's take a look. Now, I didn't draw these midpoints exact, but it's pretty close, all right? Look at this blue one right here. It connects the midpoint of these two sides. What I want you to do is I want you to look at this blue one and look at the, I'll tell you what, let's do this. Let's make that blue, and I'm just going to do this. I'm going to just draw over top of it so we can refer to both of those. Look at the two blue ones. Everybody looking at it? I don't know if this is going to come out perfect because I just kind of eyeballed where the midpoint was, all right, but it should be pretty close. So watch this. If I copied this blue one right here and I pasted it, and I put it, if I can grab it, come on. When it's this skinny, oh, come on, I'm going to blow it up. Maybe it helps. There we go. Okay. Now watch this. See what I did? I took this one right here, I copied and pasted it. So this length is the exact same length as this. Agreed? So look what I did. Somebody come up with a conclusion about the lengths. Look at that one right there. That's exactly what? What's this length? It's what of this bottom blue one? It's half of it. Exactly right. Okay, that's what I want you to see. Okay? Everybody see that? That the midsegment, got such a hard time grabbing these lines. There it goes. Watch. This midsegment right here, what do you think if I compare it to the opposite side? It's what? It's half. It's not equal. Look, that is not equal to this whole side right here. It's what of the whole side? It's half of it. That's exactly right. Okay, or you could say that the opposite side right here, this third side, is how much of the midsegment? This third side, this blue one right here. No, this blue one is how much of this midsegment? Listen to me. This blue one right here, this one that I'm pointing, not this one, okay? This one right here, this blue one right here, okay? What is that compared to this? Is it equal? Is it half? This bottom one, from here to here, it's not 2/3. It's a good guess, but To tell you the truth, it's not really that great of a guess because I've already shown you this. We've already said. Can't see what? Oh, you can't see this? Oh, okay, I see. Right. Okay, I'm sorry. All right, yeah, I was pointing to it, and it kind of blends into the screen a little bit up there. I didn't realize that, but thanks for pointing that out. All right, so this, I tell you what, let's make this, let's put some letters in here so I don't have to say this one, that one. All right. Hold up. Let's just call this ABC and D and E. Okay. All right. Now we can refer to letters, and let's put an F in there. All right, right there. Look at DE and look at BC. Everybody see that? BC is the third side because this is the midpoint of two of the sides. This is the third side. What I'm asking is this. I'm asking, tell me about the length. The length of BC is how much of the length of DE? It's 2 times. Exactly right. Because we said earlier, right, that DE was how much of BC? Half of it, right. So if BE is half of BC, right? Do you see it? See how it's half? Right? Because this DE is this much. So BF is there and FC is right there. So it takes 2 of these to make, it takes 2 of these right here, right, to make that whole entire BC. So BC is twice as much. Let's write it down. BC is what? Twice as much as what? DE. Everybody see that? Okay. There's something else that's true. Remember yesterday, we took a lot of time to do the distance formula, but what was the thing we did before the distance formula? We found the slope. So there must be something else that's true about this. Okay, what about the slope? What about the slope of BC and the slope of DE? What do they look, just eyeballing it, what does it look like they possibly are? The slope. We're not saying half, we're not saying twice. Yeah, it's rise over run. So tell me about the slope. How is it slanted? Look at DE and look at BC. How is it slanted? Tell me something about the slope of DE and the slope of BC. Okay, you could say it's 0 if you knew it was horizontal. We don't know it's exactly horizontal. But compare the two. I want you to compare the two. We don't say slopes are congruent. We just say that they're what? That they're equal. We just say they're equal to each other. Okay? We say the slopes are equal to each other, which means if the slopes are equal to each other, you would be absolutely right if you said parallel. Okay? So look, this DE would be parallel to BC. But what's true about the slopes? The slopes are equal. Okay? The slopes are the same. Right? That's just by eyeballing it. All right? There is a proof that we could do. I'm not going to, but we're going to do something a little bit later. All right? So let's write that down right here. So let's say the slope of BC, that little m means slope. I'll tell you what, I'm not going to write m because sometimes that might look like the measure of an angle or something like that. So I'm not going to put m. I'm going to say the slope. Okay, the slope of BC, this big blue line down here, is equal to, what do you think? The slope of, let's use the letters. BE? DE. Okay. I was hoping you'd say. Okay. The slope of DE. You see it? That this slope right here and this slope are the same. Which means if the slopes are the same, they must be parallel to each other. Okay? Now that's true about all 3 of the midsegments. So let's say, I'm not going to write them all down, but let's just do this. Look at DF. What do you think you're going to compare DF to? It connected the midpoint of these 2 sides. So what's the third side? FE is not the third side. It's not the third side of the triangle. Look, DF connected the midpoint of this side, and it connected the midpoint of this side. What's the third side then? AC. So tell me something about the length of DF compared to the length of AC. What do you think DF is? DF is how much of AC? It's half of it. Exactly right. What if I said it the other way? What if I said, what's the length of AC compared to DF? It'd be twice as much, okay? What do you think is probably true about the slopes of DF and AC? Look at it. Do they look like they slant exactly the same? Yeah, absolutely. So what do you think is true about their slopes? That they're slopes. What's true about their slopes? They are equal to each other, right? The slopes are equal. Now, we could say that the line segments or the lines are parallel to each other, because anytime you have two lines that are parallel, they have the same slope, okay? You with me on that? What's the other one? The pink one, EF. So EF right here must be what of another side? Half of AB. Good, you're getting it now, okay? So EF right here is half of AB. Or you could say AB is how much of EF? It's twice, okay? So AB is twice as big as EF. Because if I picked up this EF and moved it here, it would probably go from A to D, wouldn't it? And then another one would go from D to B. That looks like it might be off just a little bit. This looks like it might have to be up here a little bit. But again, I just eyeballed the midpoints, okay? We weren't really particular about it, okay? So that's pretty important stuff. So they could put some numbers in here, couldn't they? They could say that DE was, 5. And they would ask for BC. What would BC be equal to if DE was 5 and DE was the midsegment? BC. What would BC be? It would be 10. Exactly right. Everybody see that? Yes. Right here? That's an arrow to indicate that this line is parallel to this line. This right here says triangle midsegment theorem. Okay. I'll make it so you can see the whole page. All right, it is. So that's what we're going to do. So BC would be 10, wouldn't it? What would BF be equal to? BF. B as in boy, F. It'd be 5, that's right, okay? Because DE would be the same as from here to the midpoint, wouldn't it? Okay, so BF would be 5, and then FC would what? Be 5. So that means BC would be 10. Everybody got that? Okay, so that's pretty important stuff. Slopes are going to be the same. The midsegment is half of the third side. If you can remember that, the midsegment is half of the third side. We got that? Now, you know what else they could do? They could say stuff like, I'm just going to make this up. I don't know if this will come out nice and even or not. Let's take a chance. Let's get rid of this. They could say that this is like x plus 2, and then BC, let's do this. Let's say BC was, 5x minus 1 or something like that, okay? I'm just making stuff up. What if they ask you to solve for x and then solve for DE and BC? What would you do with these? Would you set them equal to each other? Again, what's the relationship? DE is what of BC? It's half. Or you could go the other way and say BC is twice of DE. I'd probably use that one because I'd rather not have to use a half, wouldn't you? So watch how we would set this up. I would say that BC, which is 5x minus 1, again, I don't know if this comes out nice and pretty or not, but this is how you would set it up, is what? BC is how much of DE? It's twice as big, so what would we do? Put a 2, twice as big as x plus 2. So what do I do with that 2 and that x plus 2? I would multiply them together, wouldn't I? Do you see what I just did right here? Everybody look. I've been asking you this 3 times with these midsegments. BC is how much of DE? It's twice as much, right? So here's BC equals 2 times, that's twice, correct? 2 times the midsegment, okay, which is DE. Everybody see that? The third side is equals 2 times the midsegment. Okay? And then, what could you do with this? What could you do with this thing right here? Solve it, right. Solve for what? Solve for x. Let's do it real quick, okay? Again, this is just kind of off the cuff. I don't know if it's going to come out pretty or not. Probably won't. But what's this going to be? 2 and then a parentheses x plus 2. What do I do there? Distribute. Do you remember distributive property? from Algebra 1? It's a basic Algebra 1 thing. So it's 2x plus what? Plus 4. Now, we got to get x's on the same side. Okay, so we subtract a 2x, subtract a 2x. And then what do? We got rid of the 2x's. What do I do with this minus 1? You could bring everything down, but let's just do it in the same step. In Algebra 1, a lot of teachers always bring it down every single time. But the more you do it, the more you get used to just getting rid of it right now. So how do I get rid of a minus 1? Add a 1. So where do we add a 1? We add it over here. 5x minus 2x is 3x. That canceled, right? Equals what? Now, this doesn't come out pretty. Like I said, it probably wouldn't. But that's okay. It's no big deal. Divide by 3. Divide by 3. And that's basically your answer, is 5/3. It's not basically. It is your answer. Okay, so that's what x would be. Now, probably in a geometry book, in a high school beginning geometry book, they'd probably make x come out nice and pretty, right? And then you would just plug it in and figure out what that length is. Like, let's just say that this was a 6 instead of a 5. Is that all right? So what's 6 divided by 3? It's 2. So let's just say it came out to be a 2. So what would the length of DE be equal to if x was equal to 2? It would be 4, because 2 plus 2 is what? 4. Now, BC should be what? If this is 4, BC should come out to what? 8. All right, let's see if it does if x was 2. Now, I know I'm messing things up a little bit because x didn't really come out to 2, but I'm just saying, let's say if it did. Then what would you do? Put it in here. 5 minus... Well, it's not going to work because, yeah, this is not going to work because I just changed the answer from 5/3 to 2. So if you put it in for here, it's not going to work. But if you get DE and you got that to be 4, what's BC? It's 8. Okay, as simple as that. Yeah. Okay? All right. I think I went a little too far ahead, but let me show you what they're going to ask you to do. Let's see. I'm going to go right to example 3. So I'm skipping around a little bit. I'm trying to make this a little bit easier for you. So let's give it a shot. So here's something that they could ask on a homework. I could ask on a quiz or a test. Okay? So it's important that you write this stuff down. And let's see. So, hold on. Use example 1 to find the slope and length of the other two mid-segments of ABC. Yes, sir. Yeah, it's just showing you the distance formula, and then you're going to see that the mid-segment distance is half of the third side. That's basically what the proof says, and then it's going to also show you that the slopes are all the same. Yep, that's exactly what the proof's going to say. All right, let's take a look at this. Let's write this down. Ready? Yeah, let's stop singing, please. This is not choir. Let's not sing in here. Everybody should be writing this down. Right, I know. I take 3 seconds to pause to look at something and everybody goes crazy. I just don't get that. It's just beyond me. All right, today you have. All right, let's do this. Let's write these 3 points down. And what we're going to do is we're going to graph these 3 points. Let me see if my graph has what goes all the way to -7. I don't know if it goes that far or not. 1, 2, 3, 4. Yeah, I think this works. All right, so what I'm going to do, we're going to make this where I don't just have to eyeball it, where I got graph paper, and it's going to hopefully work out real nice for us. Okay, so I'll try to make it full screen so we can see it. All right, so there's a big old graph right there. All right, let's do this in, I don't know, yellow. Does yellow show up good on the screen? Okay. Yes, I said write this down. That means you put it in your notes. Review the video. I said it like twice. Now I said it 3 times. So here we go. Let's plot A, B, and C. And we're plotting 3 points. So guess what we're going to get out of it? We're going to make a what out of it? 3 points. We're going to make a what? A triangle. Very good. So we're going to get a triangle. So let's plot the points negative 7, 1. Do I have 7 places? I hope I do. 1, 2, 3, 4, 5, 6, 7. Sure do. Negative 7 what? 1. So that's point A. Everybody got that? We did this a long time ago. Girls? Let's plot point B. So it's going to be 1, negative 5. So 1 and the x direction, negative 5. 1, 2, 3, 4, 5. Put a point right there. We'll call this B. Third point is 7, 3. So I go over 7. 1, 2, 3, 4, 5, 6, 7. Go up 3. 1, 2, 3. Put a point right there. We'll call this C. Now what am I going to do with those 3 points? I'm going to connect them, make a triangle out of it. Okay? So there's one side of my triangle. Here's another side of my triangle. And here is the third side of my triangle. Take a wild guess on what we're going to do here. What do you think we're going to do? We're going to find the what of the triangle? Yeah, not just slopes, but what's this lesson been all about? What's the definition? Thank you. It's the mid-segment. That's what we've been talking about the whole time, okay? So we're going to find the mid-segment. We're going to find the mid-segment of all 3 sides. That means we have to find the...
Do you think the room is cold?
It was when I first came in here. It's always at 65. I turn it up.
Well, they have heat and cold at the same time.
Yeah, I don't know if I'm doing it right. I always turn it to the left to the heat.
You want me to put it only in heat?
Yeah. Is that why it gets cold all the time? Okay. I thought, like, if it got, like, above 70, the cool would kick on or something and knock it down. I wasn't sure how it worked. All right, let's everybody look at this. So if we're going to find the mid-segment, and you know these points, what do you think we're going to find first? Before we actually draw the mid-segment, what do we need? We need to find the what? The midpoint. Yes, we need to find the midpoint. Okay? So let's find the midpoint. And we're going to do it 3 times. Why are we going to do 3 midpoints? Because there's 3 what? There's 3 sides to a triangle. So we're going to find all 3 midpoints. Okay? So let's go ahead and try that. We did it yesterday. I'm going to go kind of quick today. I'm not going to like go through the whole thing, but let's find the midpoints. So 68 is good. 68? 70. Yeah, keep it 70. 70 is good. Stop it. I know what you're doing. I'm not an idiot. So knock it off. I wasn't even looking at you. Okay, let's take a look. So, what do you think? I'm 100 years old or what? Let's find the midpoint of all 3 of these sides. Let's do AC first. I don't know why. It just looks like maybe that's the midpoint right there, doesn't it? Kind of looks like it. So let's see if it is for sure. Okay, let's do the math. Find the midpoint of AC. How do we find the midpoint? We did this yesterday. That's why we did this yesterday, so we could do this right now. So we take AC, right? There's A and there's C. What do we do with the x's? We add them together. So it's negative 7 plus 7, right? And then we add the x's. It's 1 and 3. I know that's kind of small, just trying to fit everything in there. And we should be able to do this in our head. Negative 7 plus 7 is what? 0. 0 divided by 2 is 0. 1 plus 3 is 4 divided by 2 is 2. So what's the midpoint of AC? 0, 2. Look at it. 0 on the x and then 2 on the y. Yep, it's right where we thought it would be. Right there. Do you agree? So that's kind of cool, right? We did the math and it shows up exactly where we thought. Let's do another midpoint. Let's do AB this time. So AB, my guess is probably right there. Do you see that? I know you can't see the cursor very well, but you can kind of see it a little bit. It's right there. So let's do AB. Let's find the midpoint of AB. If you can do midpoints, you should be able to do these pretty quick. So let's do AB, these 2. In fact, let's just add them. Let's not write it down. Let's just add them in our head. So what are we adding? The negative 7 and the 1. What's negative 7 plus 1? Negative 6. Negative 6. Let's add the y's with the a and the b. So it's 1 plus negative 5. What's 1 plus negative 5? It's negative 4. So let's do that. What's negative 6 over 2? Negative 3. What's negative 4 over 2? It's negative 2. So the midpoint of AB should be at negative 3, negative 2. Let's see if it looks right. So we start here. We go negative 3, 1, 2, 3. We go negative 2, 1, 2. Yep. That's exactly where I thought it would be, right there. Everybody got that? Okay. What about this one? Midpoint, my guess is probably right there. Do you think? Okay, can you see the cursor a little bit? It's right on the yellow. It's right there. So let's try that. So let's do BC. Midpoint's getting pretty easy now the more you do them, isn't it? Let's do BC. B and C. Let's add up the x's. So 1 plus 7. What's 1 plus 7? That's 8. Let's add up the y's. Negative 5 plus 3. That's negative 2. What's 8 over 2? 4. What's negative 2 over 2? Negative 1. Let's see if it is where we thought it should be. It's 4, negative 1. So I go 1, 2, 3, 4, negative 1. Yep, that's exactly where I thought it would be. Right there. Let's call these points D, E, and F. All right, so let's call this one D. Let's call the 4, negative 1 E. And let's call this one F. Okay? Now we got midpoints. So guess what we can make now? We can make mid what? Mid segments. So what do we do to get the mid segments? We just do what? Just connect them, right? So I'll keep it all the same color this time instead of changing to 3 different colors. And then I go from midpoint to midpoint, and then midpoint to midpoint right here. So those are our 3 mid segments. Everybody good? So what we want to do is we want to see if what that theorem says is actually true. Or not just to see if it's true, but we want to find the actual lengths. Let's find the length of DF. And once I find the length of DF, I should be able to figure out what the length of BC is. Okay? So how do I find the length of a segment? What formula do I use? The distance formula, that's right. Tell you what, I'm going to get rid of this just so that I have some room over here. And I'll tell you what, let's do this as well. Let's move this whole thing. I got to grab everything here. Let's just push it over to the side so I have some more room to write. Is that all right? Okay, so now what we're going to do is we are going to find the distance. I'm not going to do this to every side because of time, all right? But we could do this to every side and every mid-segment to see if it works, okay? But let's just do, I don't know, which one do you want to do? Let's do AC and FE. Is that all right? All right, so let's not do this one, and let's not do this one, just for the sake of time. That's the only reason. So what I want to do is I want to find the length of FE. If I know the length of FE, I should be able to find the length of AC. Agreed? Yeah. All right. Or I could go the other way around. I could find the length of AC and then take half of it, and that's the length of FE. Let's do it that way, since I already got my points here. Is that all right? So let's do the distance formula. So the distance is the square root. We did this a bunch yesterday, so it should be familiar to you. We had a whole test on it another chapter ago, something like that. What do we do with the x's? We do something with the x's. What do we do with the x's here? We subtract this time for distance formula. So we are going to subtract. What are we trying to find? We're trying to find the length of the distance of AC, all right? So A and C. So there's A and there's C. So let's find the length. So we subtract those x's. It's negative 7 and 7. So we go negative 7 minus 7. Everybody see that? Because we subtract them. It doesn't come out to a 0 this time like it did with the midpoint. It's going to be something else. And then, again, we're doing AC. Let's do the y's. So it's 1 minus 3. 1 minus 3. Let's see what we get. Keep the square root there. Don't forget that. What's negative 7 minus 7? We did this yesterday, I think. Same exact numbers. It's negative 14. Add a line, change the sign. It's negative 14. Okay, and we square that. What's this? 1 minus 3. It's negative 2. And we're going to square that. 256, is that 14? Who's got a calculator? 14 squared, 14 times 14. I think it is. Somebody double check. 196. I knew it ended in a 6.
I know 2 times 2.
So 196 plus what? 4.
Which is 200.
Which is square root of 200. Yeah, we did this yesterday. Remember that? Okay. Because this is taken from the first example. But I want to show you something that's really important. So what is this? Remember we did this. I'm not going to go through the whole process. It's 100 times 2. What's the square root of 100? It's 10, and then the square root of 2. And you're like, well, that's a dumb number. Well, I just want to show you something. So that whole AC right there is 10 square root of 2. Let's find FE. I'm going to erase this just so I have some room. Don't erase it on your paper, but I'll erase it here. Let's do FE. So what was the point F right here? It was what? 1, 2, 3, 1, 2. So point F was -3, -2. What was point E? It was 1, 2, 3, 4, -1. It's just a little easier if I write them down, right? And then you can see them. So now what we're going to do, let's find the distance of FE. All right, we're going to do the same exact thing, except we're just using different numbers this time. So I guess it's not the same exact thing, but you get the idea. All right, what do we do? Subtract the x's. -3 minus 4, -3 minus 4. Subtract the y's. Now be careful with this. It's -2 minus what? Not just a 1, but what is it? It's a -1. That's important. A lot of people forget that. What's negative? Let's put a square root for equals. What's -3 minus 4? It's -7 squared. Now what's this? Minus a negative. What happens to that? Becomes a plus, doesn't it? -2 plus 1 is -1, and that's squared. So let's see what we get. What's this? 49 plus 1. Agreed? Yeah? Okay. I think this works. Yep. Square root of, what's that? Square root of 50. Now, let's see if we can do that square root thing. I know this is not officially algebra, but obviously we do a lot of algebra in geometry. So how do we break this down? Like what times what is 50? I'm not going to use 5 and 10. What's another thing? 25 and 2. Not plus, it's times 2. 25 times 2. What's the square root of 25? 5. And then what? The square root of 2. So watch this. This is 5 square root of 2, which is, now, all that to show you this, that would you agree that the mid segment is half of the third side? Is it? Is 5 square root of 2 half of 10 square root of 2? What if you didn't have the square root of 2? Watch. 10 square root of 2 divided by 5 square root of 2. What happens to the square root of 2's? Cancel out. Anybody remember Algebra 1? Way back from last year? What's 10 over 5? It's 2. So what does that mean? That means that this is twice as big as this. Do you see it? Because 10's twice as big as 5, right? Okay? Forget the square root of 2 part, but yeah, so AC is twice as big as FE. So that just shows that the mid-segment theorem actually does work, doesn't it? It's not a proof of it. It's just an example of it, that it actually does work, all right? You could do that. Again, we don't have time, but you could do that with the other mid-segments as well. You could find the distance of DF, and you're going to find that it's half of BC. You could find the distance of DE, that's a mid-segment, and that distance will be half of AB. So if we wanted to do all three of them, we could. But I think you're fine just seeing it works with one of them. It'll probably work with the other two as well, wouldn't it? Yeah, I would think. Okay? Let's see. What else? Oh, the slopes. Let's see if they're actually parallel to each other. So what are we going to do? Let's do some different colors so we don't get all mixed up. Let's scooch it up here. Let's find the slope of AC. So slope, M equals. Remember how to find the slope? Rise over run, subtract the y's of AC. So AC, let's subtract the y's. Which ones are the y's with A and C? The 1 and the 3. So 1 minus 3. Let's subtract the x's with the A and the C. So it's -7 minus 7. Let's see what our slope is. That's -2 over what? -14. Reduce that. What is that? 1 over 7. So the slope of this is 1 over 7. If you look at it, it should make sense. Because look, let's go from A to D. Let's rise. How much do I rise to go to A to D? Rise 1, and I run how much? 1, 2, 3, 4, 5, 6, 7. Sure enough, that is the slope, isn't it? We saw it mathematically, and we see it graphically, right? It's rise 1, run 7. Okay, or it's rise 2 and run how much? 14. That's still a slope of 1/7. Agreed? So what do you think the slope of FE is? If you wanted to count, you could. Watch. Go from F to E. So I rise 1 and I run 1, 2, 3, 4, 5, 6, 7. Right there. There's 1 over 7. So the slope of FE and the slope of AC are exactly the same. That means that AC and FE are parallel to each other. Okay? So there's a lot of stuff that we know just because we connected midpoints of a triangle. Who would have thought that there was so much stuff to know just by connecting midpoints of a triangle? But that's what's cool about this stuff is, nobody like came up with it. Nobody like invented this. It just happens in nature, okay? I think God designed it, to tell you the truth, okay? I don't just think it, I know it. Okay, I know that God designed all this stuff. And you may think this is insignificant. You're probably thinking, well, who cares about a midpoint and connecting midpoints of a triangle? But it's just one little thing. It just shows you the detail, I think, that God puts into things that makes things work out like this. And I think that's pretty incredible. So there you go. So you do have a homework tonight. It's what we backed up a day. So you're doing a Wednesday's assignment. You're not doing Thursday's assignment. You're doing Wednesday's assignment, which is, let's not stop. Let's pay attention. It's page 196, 197. And it's 1 to 16. And this is section 4-7. Whoops. Okay. So there you go. That's the section.